Hello guys, my name is Diego Fierro and today we'll be covering atomic structure and nomenclature. Now this section is going to be divided among three videos. In the first video, which is this one, I'm going to go over a brief introduction about the periodic table as well as covalent and ionic compounds. Now here we have a periodic table, and what is within this periodic table? So within this periodic table we can see different types of elements such as hydrogen, carbon, nitrogen, aluminum, and so on and so forth. Now, how can we distinguish each element? The way by distinguishing them, we can look at the metals, the metalloids, and the nonmetals depicted in these specific colors. The metals are this silver metallish color, the metalloids are this greenish color, and then the nonmetals are this golden color. Now, take note of these red plus and minus numbers that we'll be going over shortly. Now, compounds, what are compounds? Compounds are the formation of two elements forming a bond and forming a compound or a substance or a structure that is bigger. So, a quick thing to note is that some of these elements like to go in pairs, such as hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine, or as you can see in this mnemonic, have no fear of ice cold brew. It's a way of remembering that hydrogen, for example, that hydrogen likes to be paired up with another hydrogen. So you will never see a hydrogen just by itself. You will most likely see an H2 or an N2 for nitrogen or F2 for fluorine, and so on and so forth. Now, what makes an element? So what makes an element are subatomic particles. Some subatomic particles are the protons, neutrons, and electrons. Protons, neutrons, and electrons. Protons, neutrons, and electrons. Now, protons are positively charged particles, and neutrons are neutrally charged, or they have no charge. Electrons are opposite of the protons, but are attracted to protons, so they have a negative charge. Now, protons and neutrons can be found within the nucleus. And the sum of the protons is what gives you the atomic mass. The atomic mass of a special element. Now, the electrons aren't considered into the atomic mass since their mass is about 1,000 to 2,000 times lighter than that of protons and neutrons. But they do surround the nucleus or the center of the atom, and they form what is known as the electron cloud. Right. So we look at this example right here. We look at this example, and it's an example of the periodic table. So we have the atomic symbol of hydrogen, H, and we have what is known as the atomic number, or the number of protons that hydrogen has, or the significant element has. In this case, hydrogen has 1, so it has 1 proton. Now the number on the bottom is the atomic mass, right? And this can be known as AMUs, or the atomic mass unit. And that is the sum of the neutrons and protons. Now, we also have some special elements that can be known as isotopes. Isotopes is basically when an element has more neutrons than protons. More neutrons than protons, right? More N than P, more neutrons than protons. This can be seen in these following examples, 1, 2, and 3. So the way we say these is hydrogen 1, hydrogen 2, or hydrogen 3. And the number on top states how many neutrons there are in that hydrogen, but you see that the bottom number, or the amount of protons, doesn't change. This is because hydrogen only has 1 proton. Now, if that proton was to be different, then the element would be different. Now we move on into covalent or molecular compounds. Now, how are covalent compounds formed? Well, these covalent compounds are formed through the bondage of nonmetals and nonmetals. That is to say, this example of carbon dioxide, which carbon is a nonmetal and oxygen is a nonmetal. So then these two will give you carbon dioxide. Right? Carbon dioxide. Now, how do we name these? How do we name these covalent compounds? Oh, one thing I forgot to mention is that covalent compounds are formed through the sharing of electrons. They share electrons, and that's how they bond to each other. Uh, and that's how nonmetal to a nonmetal would bond. Now, how do we name them? Well, we name them by using the Greek prefixes, such as mono, mono for 1, di for 2, tri for 3, tetra for 4, and so on and so forth, till we go all the way to deca for 10. Now, the same example of carbon dioxide. We are used to reading this name out as carbon dioxide, right, with the Greek prefix di for 2 oxygens, right, 2 oxygens. Now, why is it that we don't say monocarbon? Monocarbon. Since it's implied that it's only one carbon and it's the first element in the compound, we don't have to state that it's one, since it's given. So the simplest way of saying monocarbon dioxide would just simply to say carbon dioxide. Now, let's say you had something like water, right? H2O. Now, this hydrogen would be dihydrogen, 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 since it does have, since it has 2 hydrogens, and we would use the di suffix or prefix, and then for oxygen we would use the mono, since it is after the first element. Since it is after the first element, then we would use the number 1, and so we would just say monoxide, monoxide, right? Right, monoxide. So these are ways that you can name different types of covalent bonds. Next, we will cover alkanes. Alkanes are still covalent bonds. But the difference between these bonds and that of regular covalent bonds is that it's a compound with just carbons and hydrogens. Just carbons and hydrogens, and the way we name this is by looking at the number of carbons. Right? The carbons, and we add ane to the end. So, for example, the Greek prefix for a covalent compound for 1 carbon would be mono, and then we would add ane. However, please take note of this. This is important. We don't use mono, di, tri, or tetra from the numbers 1 through 4 for the prefix of alkanes. For the prefix of alkanes from 1 through 4, we use this mnemonic right here. This mnemonic right here, stated in white, Maria eats peanut butter, or methane. Let me grab another color here. Or methane, ethane, ethane, propane, and butane. After these four, we then start using regular Greek prefixes such as pentane, hexane, heptane, octane, nonane, and decane. Now, let's see this example right here. Now, in this example, we have one carbon. Right? And we know that from one carbon, we don't use the prefix mono. Instead, we would use methane. So in this case, this one carbon would be known as methane. Methane. And this is a nice form of knowing how to name alkanes. Now we go on into ionic compounds. Now, ionic compounds are different, or is the type of compound that is usually compared to covalent compounds. So an ionic compound is that of a nonmetal with a metal. And so The way this bond forms is that the metal likes to gives electrons to the nonmetal, and the nonmetal gives electrons to the metal. Now, the metal, since it gives electrons, it becomes more positively charged, and so it becomes a cation, right, over here. And then the nonmetal likes to receive those electrons from the metal, and so it becomes this anion, this negatively charged compound. So this negative charge and this positive charge from the metal and nonmetal is what ultimately attracts them to each other, and that's how they are able to form this ionic compound. Now, how do we name this ionic compound? An easy way to remember is just to write the name of the metal first, then state the name of the nonmetal, but change the suffix of that metal to "ide." Right? Suffix to "ide." Now, take for example barium. We see that barium, we have the metal, the name of the metal first, barium. Then, instead of saying chlorine, we say chloride, since we changed the suffix here to chloride, to "ide." And this would make it possible to name it BaCl2. Now, how is it that we got two chlorines into that one barium? Now, we see that charges take into effect here, such as the cation and which one's the anion. Now, how do we get these charges, you may ask? Well, we look at the numbers that were on top of the periodic table. I don't know if you noticed in the beginning that there was these numbers on top, that 1 plus, 2 plus, 3 plus, 3 minus, 2 minus, 1 minus. That is to indicate that the hydrogen, this whole row here, is a positive 1 charge. This whole row here is a positive 2 charge. Then this one has a positive 3 charge. Nitrogen column has a minus 3 charge. Oxygen has a negative 2. And fluorine, or the halogens, are negative 1. Now, that is an easy way to remember. The other ones, it varies through problems, and metals, they usually have a specific charge assigned to them. But we will be going over that in the next, in another section. Now, this is how we get the charges. Barium has a positive 2 charge, and chlorine has a minus 1. And the way we are able to add it to the subscript, or know how many there are of each, is that we add the charge to the subscript in the bottom. So this positive 2 charge will become a 2 down here in the chlorine, and this negative 1 will become a simple 1 down here with barium. Now, why is it that we don't write this 1 when we write barium chloride? Right? We write it like this. We don't write that 1 in the bottom, because it's implied that there's only one barium, since we only see one barium here, and there is no number next to it. Now, a quick summary. Covalent bonds can be named through their Greek prefix, and it's a compound formulated by a nonmetal, and another nonmetal. We also use the prefixes, the Greek prefixes, to name these, such as mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, right? 1 through 10. Now, alkanes, or as the name implies, alkane, we change the prefix of 1, 2, 3, and 4 carbons to methane, ethane, propane, and butane, and then we follow from the prefix for the 5th one all the way to the last one, right? So it would be decane, nonane, octane, heptane, hexane, and pentane, right? Now, for ionic compounds, we see that the compound is formulated by a metal and a non-metal. Now, these give their electrons, while covalents share their electrons. And how do we name this? We simply state the name of the metal followed by the name of the nonmetal, and we use the suffix "ide" to demonstrate this bondage. And as well, we look at the charges, such as barium has a positive 2 charge, and chlorine has a negative 1 charge, and so we switch these to get barium chloride, or the written form barium chloride. Now, I hope you guys were able to learn something from this video. Please feel free to leave a comment if you were stuck on something, so I may give you an answer to or help you out in the future. In the next video, we'll be covering polyatomic ions and oxide ions and all that lovely jazz. So, thank you for your time, and I'll see you next time.